These are what scientists are doing. This is quantum computer. Contoh, okay, sekarang komputer pada hari ini, kalau kita nampak, okay, this is shilling, duit coin. So this is a coin. So kalau pernah ada coin, can you please tell me, ada berapa side dalam coin? Coin, dekat coin.
Two.
How many sides do we have?
Two.
Only two. Satu bahagian yang ada bunga contoh, satu bahagian nak nombor contohlah. Okay, so kalau dalam bahasa komputer, bahagian ni satu. Okay, kalau belakang dia digit 0. So in computer now kita nak programkan dia hanya ada digit 1 dan juga kosong. Dan kita ini komputer sekarang digit 1010. For quantum, okay, we have combinations of 1 and 0 dalam satu sekali tu. Okay, dia ada superposition. So this is what we 0 and 1 are superposed. Okay, mereka superposed 0 1. So this is what we call qubit. Okay, now you don't have to memorize all this. Sekarang ni saya masih lagi bercerita nak bagi awak big picture kenapa kena belajar quantum physics ni dan membuatkan kita faham apa yang berlaku sekarang ni. Sekarang ni you just apply kan. Awak sekarang ni menggunakan saja komputer. Tapi ada orang mencipta komputer yang lebih hebat. Lady cerita tentang how you can control a flight ataupun an aeroplane from the ground. Dengar tak dia cakap tadi? Maksudnya aeroplane tu ataupun plane tu ada, the aircraft has dia punya pilots kan? Ada pilot dekat atas. Sepatutnya apa? Pilot yang bawa the plane kan? But with quantum theory ataupun with quantum physics, you can hack the system up there daripada ground sahaja and vanish. The aircraft can macam aircraft tu still in the air, tapi dalam sistem kan, dalam komputer yang orang yang control dan tengok traffic pada air traffic tu kan, tengok dekat langit tu, traffic dekat langit tu, dia dah tak nampak dah, hilang dalam radar. Itu yang dia cakap tadi tu. Okay. Itu semua boleh dibuat. Itu perkara biasa. Awak tengok movies kan, what you watch in the movies adalah apa yang sebenarnya mereka sedang buat. Itulah kelebihan mereka tu. Okay. Right, saya bukan nak cerita negatif lah, tapi saya nak bagi tahu orang boleh gunakan ilmu ni untuk kebaikan dan juga untuk keburukan. That's why lah kita as human being, kalau ada yang Muslim, untuk Muslim kita kenalah kuasai ilmu ni untuk kita, sebenarnya kita bagi tahu manusia-manusia ni benda-benda ni boleh dimanfaatkan. Kenapa nak buat untuk keburukan kan? Okay, so ni this lady dia tengah cakap tentang dia adalah senior ataupun dia adalah pengarah yang menentukan sistem dalam ketenteraan Amerika menggunakan physics punya konsep. Okay, so that's how physics can control the world. Okay, so this one panjang lebar ada cerita pasal ketenteraan. So this is what they have. Okay. Okay, so ni buat. Okay. Apa lagi? Okay, yang this lady pula dia cakap pasal apa? Siapa dengar? So this lady was talking about dia tengah ni dekat di University Microsoft Microsoft University. dia tengah buat research macam mana contohnya untuk menggerakkan power ke kuasa. They are all talking about power. So, dia kata macam mana dia nak transfer power macam dari satu negeri ke satu negeri dengan cara paling efektif hanya dengan tekan satu button from a computer. Boleh transfer the energy very effectively. Okay. Ada soalan sekarang. So, adalah ni semua cerita tentang negativity lah dia kan. Bahaya dia. Sebab sebab semua orang nak control dunia kan. Jadi, China pun berlumba-lumba. Dia kata dulu China hanya menonton saja apa yang orang buat. Now China pun is very advanced kan.
Electromagnetic spectrum.
Okay, so this one is electromagnetic wavelengths and also frequency. Okay, disusun I arrange this one. This is in the arrangement of increasing wavelength to the right. Okay, ke arah sini increasing wavelength. Okay, and then you know lah. So kalau wavelength makin besar, the value is bigger, the frequency is smaller. And then you need to know when frequency is high, kat sini frequency high, but wavelength is very small. Ni. Okay, so you need to know when frequency is very high, what happened? The power, the wave has very high power. It depends on the frequency. Okay, now you learn that the electromagnetic spectrum is a continuous spectrum. Okay, so this spectrum ada 7 types of waves. Okay, with different frequencies and wavelength. Okay, okay, and then okay, kita tengok lagi introduction lagi in this topic. Okay, all objects emit electromagnetic radiation. Okay, semua benda dalam dunia ni emits ataupun mengeluarkan haba. Okay, now cold objects emit waves with low frequencies. Okay, ada juga haba dikeluarkan, but the frequency is low. For example, radio waves or microwave. So nak katanya radio waves and microwave also emit heat. Okay. Okay, but when we talk about hot object emits waves juga. But the frequency is higher. Okay, so example, visible light and UV radiation, ultraviolet. Okay, okay, ini tak ada apa-apa yang memeningkan. You understand this kan? Faham kan? Okay, then right. So and then people are talking about black body. Apa black body ni? Okay. So what is black body? So black body is an idealized body that is able to absorb electromagnetic radiation that falls on it. Okay, absorb heat in electromagnetic radiation form. Okay. Now a black body can also emit thermal radiation depending on its temperature. Okay. Fahamkan pelan-pelan The radiation emitted forms a continuous spectrum and is unaffected by the nature of the black body surface. Thus, an object emitting electromagnetic radiation, which is determined by its temperature, is known as a black body radiator. Okay, so now you need to know the term black body. What is a black body? Okay, that's number 1. And emits thermal radiation of all wavelengths. Okay, so just want to show you the graph. So here are examples of black bodies. Kenapa these are called black bodies? Why?
Emit heat.
Apa sebenarnya black body tadi? So now the question you may ask yourself, why are these called black bodies? What similarities you can see at the three diagrams tu? Apa persamaan mereka?
Dia panas je.
Okay, good. Thank you. Semua nampak ada Hubble. Now, kan? Let's talk about classical theory. Okay, bila belajar tentang physics, okay, we talk about classical theory. Okay, awak pernah dengar kan these names kan? Isaac Newton, Thomas Young, and John Dalton, J.J. Thomson. Pernah dengar kan? Okay, so their discoveries are about classical theory. Apa dia? Okay, now they told, okay, so macam awak akan baca lah nanti. Isaac Newton is talking about particle nature of light. Kenapa tentang light? Apa yang Isaac Newton bagi tahu tentang light? Dia kata light is an electromagnetic waves. Tadi kita dah tengok awal tadi kan, electromagnetic waves tu maksudnya asal ni. This is visible light. So, Isaac Newton tell us light is a wave. So that is what he said. Okay, electromagnetic waves. Okay, and then he said that light electromagnetic wave that is produced from vibration of electric charge. And okay, dia kata, sorry, salah ni. First kali Isaac Newton talk about particle. Dia kata light is a particle. Okay, but Isaac Newton, he is unsuccessful explaining the phenomena of light refraction. Okay, due to failure in comparing the speed of light in glass and air. So dia gagal lah. Dia bagi tahu, dia kata light ni a particle. Saya betulkan tadi bukan dia bukan cakap pasal light EM wave. Dia kata light is a particle. Tapi bila ada fenomena refraction. Remember you learn about refraction of light? Isaac Newton tak berjaya nak explain kenapa refraction berlaku. Okay? Next. Okay, lepas tu pada tahun 1733 to 1829, you don't have to remember the year. Okay, I'm just telling you dia masa after that. Thomas Young explain about double slit experiment. We have done this one, betul tak? Kita dah buat kan eksperimen ni kan? No, I mean kita dah tengok dah eksperimen double slit tu. Can you recall? Okay, when I talk about double slit, awak boleh recall lah apa yang sepatutnya dibuat kan? So, this double slit experiment is conducted, okay, on light, kan? Yang macam saya tunjuk last week about the experiment. And apa yang dia nampak, Thomas Young, okay, he saw that from the experiment, it showed that light is a wave. So, from that experiment, Thomas found out light is a wave. Okay, so however, Thomas Young bila dia buat lagi eksperimen, he unable to explain the radiation spectrum produced by black bodies. Okay, dia masih lagi tak berjaya. Now, after that, okay, pada masa yang sama, okay, dalam lebih kurang masa yang sama, John Dalton, apa yang atuk ni buat? So, John Dalton, he found about Dalton atomic model. Okay, apa yang dia jumpa? So, when we talk about atom, awak boleh faham lah, boleh cakap tentang atom kan? Okay, John Dalton kata, matter consists of basic particles that cannot be further divided, called atom. So, Dalton atomic model, John Dalton kata, kalau kita ada objek, let's say ini meja, sebab depan saya ni ada meja tiba-tiba kan, ada table. So, this table, Dia consist of particle dalam dia. And John Dalton kata, this particle is the smallest. Ni atom. And this atom is the smallest. Dan tak ada lagi yang lebih kecil daripada atom tu. Okay. Dan same elements have the same type of atoms. Dia kata. Ni awak dah belajar juga kan? And you also have learned that same elements have the same type of atoms. Maksudnya kalau saya ada helium gas sama je lah dengan helium gas yang lain. Betul tak? That is what we learn. And then John Dalton, walaupun dia dah buat eksperimen macam-macam, but he still unable to explain the light spectrum produced by atoms. Dia macam tak boleh nak explain kenapa, macam mana atom boleh menghasilkan light, cahaya. Okay, next. Okay, lebih kurang terkemudian sikit, kita ada J.J. Thomson. Okay, in about 1856 to 1940. So, apa dia punya discovery? He discovered about electrons. Okay, he discovered negatively charged subatomic. Dia bagi tahu, dia tahulah, oh ada proton kat sini dalam nukleus, and then ada electrons. Okay, saya lukis exaggerate lah besarkan. So, dia design eksperimen to study the behavior of electrons. So, dia lah yang banyak discover tentang what is electrons, okay, and then the characteristic of electrons. But J.J. Thomson masih lagi J.J. apa ni? Cikgu J.J. pula. J.J. Thomson ya, the name. Okay. Dia masih lagi tak boleh explain the line spectrum of light produced by an atom. Jadi apa ni? Semua orang tak boleh explain. Maka come this theory ni. Datanglah, okay, ni semua kosong ni sebab ada benda yang kita nak isi ni. Dan datanglah another theory which is called quantum theory. So this quantum theory first is explained by Max Planck. Okay, dalam tahun 1858 into 1947. What Max Planck explained? Okay, he explained that. Okay, apa yang dia cerita? Max Planck ni cuba explain to us. Okay, he introduced the concept of quantum. Okay, dia cerita tentang quantum is a discrete energy. Do you understand what is the meaning of discrete? Okay. And then dia kata electromagnetic wave emitted by a black body is in discrete form. Okay, known as quantum of energy. Dia lah yang cakap tentang discrete energy ni. So the energy in each quantum is directly proportional to the wave frequency. Okay, the intensity of the radiation is low for the high frequency waves. Okay, itu Max Planck kata. Apa pula Albert Einstein cakap? Albert Einstein, okay, pada tahun lebih kurang 1879 to 1955, okay, he talks about photons. Photon tu apa? He introduced photon. So dia kata, Albert Einstein pula kata, photon is, okay, photon has energy. So photon energy, Albert Einstein kata, is directly proportional to the light wave frequency. To the frequency. Ni yang saya cakap tadi lah. Okay. So who says this? Albert Einstein. Okay. And then Einstein's quantum theory of light was successful in explaining the characteristics of photoelectric. Okay. And then Albert Einstein, dia berjaya explain tentang photoelectric. Nama dia awak nampak tak? Photoelectric. Are you here? Stay with me? Ke dah macam drowsy, dah pening, dah ngantuk dah? Okay. So, okay, photoelectric. Okay, dia berjaya explain. Dan dia kata dan dia explain lah the characteristic of photoelectric effect that could not be explained by classical theory. So Albert Einstein trying to tell us, okay, ataupun Albert Einstein tell us, okay, he tells us that quantum theory ni tak boleh di-explain dengan teori-teori fizik yang klasik yang kita belajar sebelum ni. Gitu pula dia kata. Okay, adalah pula Niels Bohr ni, okay, tahun lebih kurang samalah pada macam tak mati lagi Albert Einstein, dia dah ada teori-teori dia. So Niels Bohr kata explain the production of line spectrum by hydrogen atoms. Okay. And then he also explained about electrons in an atom orbit around its nucleus on certain shells only. Okay, dia kata pasal elektron juga. And then Niels Bohr also explained about the transition of electrons from a higher energy level shell to a lower energy level shell emits photons. So this one, Niels Bohr ni dia cerita tentang transfer of electrons. Okay, and then finally we have Louis de Broglie kan. Okay, Louis ni 1892 until 1987. Louis introduced the hypothesis on the wave nature of particles in 1924. Okay, nampak tak ada yang benda pelik kat sini? So he's trying to tell us ada particles dalam bentuk wave. Boleh bayang tak? Einstein and de Broglie postulated the idea of the wave-particle duality. Okay, so Albert Einstein and Louis de Broglie talk about wave-particle duality. Duality ni dua lah. Apa benda yang dua tu? Okay, of light and all subatomic particles. Everyone still okay? Alright. Okay, now kita tengok ni, alright, ni quantum energy. Okay, sebenarnya, okay, when we talk about quantum energy, okay, apa yang awak tengok video awal tadi masa saya bagi awak tengok video tu, they talk about quantum energy. So this is what we just mentioned just now. Symbol E, so for energy, directly proportional to, what is F?
Frequency of light wave.
Frequency.
Frequency of light wave.
Now, right. So what is quantum energy? So they tell us quantum energy is a discrete energy packet. Bayang kalau when I tell you, okay, saya ada paket-paket goodies bag. Paket-paket goodies. Maksudnya apa? Contoh saya ada plastik, saya paketkan barang-barang dalam plastik tu satu paket. Betul tak? Satu paket. Saya bagi goodie bag kat setiap orang kan. Contoh siapa jawab saya bagi contoh lah kan. So boleh bayang tak paket-paket tu? Okay. So they tell us discrete energy packet ni adalah quantum of energy. Quantum of energy ni dia dalam bentuk discrete energy packet. And not a continuous energy. Okay. So maksudnya sebelum ni we think about, okay, sebelum ni kita belajar energi berterusan macam ni, contoh lah wave energy kan. But they tell us energy is in packets like this. Dia dihantar satu paket. Okay. Now, and then energy depends on frequency of the waves. They tell us energy depends on the frequency of the waves. Now, according to Max Planck and Albert Einstein's quantum theory, light energy exists in the form of an energy packet known as photon. So, these packets dipanggil apa? So the name of this packet ni carries energy. So nama paket-paket ni ialah
Photon.
photon. Then the photon energy is directly proportional to the frequency of light. Okay? The higher the frequency of light waves, the higher the energy quantum of photons. So this one is energy, photon energy, transferred in quantum of energy. Okay, so because of the energy is directly proportional to the frequency, so we want to make an equation. Okay, ada equation dekat situ. Therefore, we have this constant. So what is that constant? That constant is what we call as Planck's constant. Bukan awak je buat Planck. Okay, Planck's constant. So what's the value? So after they do the experiment, after they did the experiment, they get the value is 6.63 times 10 to the power of negative 34 joule second. Okay, so that is the value of Planck's constant. Now, okay, so this is the first formula you see in this topic. Next, okay. So this is an example question. Compare the energy of, okay, kita tengok dulu example ni Compare the energy of 400 Newton meter and a 750 Newton, Newton pula, saya salah sebut. Apa ni nak sebut ni? Nano. Compare the energy of a 400 nano. Nano ni apa? This is a prefix. Macam imbuhan lah. Okay, meter. What is meter? So, meter is a unit. Unit of length. So, when we use nanometer, we are saying that the length is very small or very long.
Small.
Very small. Okay. Right? So, compare the energy between these two wavelengths. Between these two energy of light photons. How do you compare? So, in order to answer this question, step 1, you identify the problem. The problem, what is the problem? Problem ni dia suruh apa?
Compare.
Compare apa?
Energy.
Okay, identify the information given. Energy apa yang dia beri? Okay, and energy of 400 nanometer photon and another one is 750 nanometer photon. Now, what information that you know? What information that you know? You know the value of? Value apa yang awak tahu? You know H. What is H? What is H?
Planck constant.
Ya, itu awak dah tahu. Ada Planck constant. Okay. And then what else you know? Kita tahu C. What is C? C is speed
of light.
Of
Vacuum.
light in vacuum.
Vacuum.
Thank you. Siapa bagi tahu tu? Bagus. Okay, saya harap saya tahu. Boleh bagi hadiah. Tapi tak dapat nak tengok siapa. Okay, so C, what's the value? Anyone know the value of C?
3.0 times 10 power of 8.
Excellent. Okay, 3 times, okay, 10 of power 8. 3 times 10 to the power of 8 meter per second. So that's the speed. Okay, itu adalah yang kita tahu. And then do we know the wavelength of each of the photon?
Yes.
Okay, so kita ada wavelength 1, photon 1. Wavelength dia adalah 400. What is nano? 10 to the power nano berapa? 10 negatif?
9.
Negatif 9. And then kalau awak terlupa ya, saya nak tunjuk kalau awak terlupa, saya dah tunjuk banyak kali, tapi saya nak tunjuk lagi sebab saya rasa ada student yang dia tak tahu. Okay, so now I want to show you my screen. 400 nano tadi macam mana? Kita tekan 1, lepas tu shift nano 3. Ni nampak ni. Okay, so dapatlah 1 times 10 to the power negative 9. So, now you know the values of wavelength. So kita ada wavelength 1, we have wavelength 2. Wavelength 2 is 750 times 10 to the power of negative 9. Unit dia meter. Okay, so next step is identify the formula to be used. So what is the formula we need to use? What do we want? We want the energy. So what is the formula of energy? So you write the formula. What's the formula? E equals to
HF.
Now, do you know, okay, now you know okay, katalah you nak tahu energy for the first one. Katalah saya panggil ni A1. Ini photon 2. So energy 1 is, kita letakkan 6.63 times 10 to the power of negative 34 joule second. What's the frequency? Do you know the frequency?
No.
So you need to find out what's the frequency. Okay, what can you do? So now, just now kita tahu, okay, C equals to, what is C? C is velocity kan? What is the formula of velocity of a wave? Velocity of wave, what's the formula? Right, lupa. Dah belajar ni last year, IGCSE, kan? Okay, kalau you terlupa. Okay, kalau you terlupa, I tell you now, this is the formula of speed for wave. Alamak, kena macam mana tu? Alah, sebenarnya taklah susah pun. So, awak tahu kan, V equals to distance over time. Betul tak? Yang ni yang familiar tak? Ni tahu kan?
Tahu.
So, distance tu kita gantikan dengan wavelength. Sebab wavelength distance ni, the unit as it is meter. Wavelength pun unit dia meter. Cuma dia jadilah nanometer ke apa meter. Faham tak? Kita tukar bentuk je. Do you get it? The first one? Dapat tak yang tu?
Yes.
Okay, next. Over T. And then you have learned, sebelum ni awak dah belajar dalam tajuk chapter 1, chapter 2. You know what is period. Do you have you come across the word period? And then the symbol of period is capital T. Okay, and then we tell you, okay, you have learned that period is equals to 1 over frequency. Pernah tak tahu kan? Okay, so from there you can get frequency equals to 1 over period. Okay, so period tu apa? Period is time. Time can be in second. So this is time. Boleh je tukar 1 over time tu. Faham tak? So from there, kat sini adalah darab 1 over T. Betul? But 1 over T equals to
Wavelength.
1 over T equals to F. So that's how we get V equals to F lambda. Okay? Make sense?
Yes.
So now, since you know this one, so ni sepatutnya dah tahulah ni ni kita pergi jauh ni sebab you terlupa. Jadi I recall balik, I ask you to recall V equals to F lambda. Tadi saya dah bagi tahu how do we get this formula. So V equals to F lambda, therefore C equals to apa? C equals to V, so C equals to F lambda. Now, now we want to solve ni. F tu berapa? Okay, therefore, for that, kita ambil apa? Okay. Jadi, because of that, we rearrange the formula so that F equals to C over lambda. Now we substitute this one into this formula back. Nampak lama dan susah sebab saya pergi patah balik banyak benda nak recallkan awak macam-macam. Tapi sebenarnya it's simple. You just substitute dia. F tu apa? Now you know the value of C. So C is 3 times 10 to the power of 8 meter per second. Then you over kat sini kan? Over what? Over
400
wavelength. So okay. So now this is 1. Jadi the 400 times 10 negative meter. So meter potong. Second negative second. So kita dapat berapa? So tekan-tekan calculator, you will get the answer as 4.97 times
10 power of negative 19.
Negative 19. What's the formula? What's the
Joule.
unit? Joule.
Joule.
Okay, and then we do the same for E2. Dapatlah E2 pun sama. Okay. So this one is what? What is this value?
Planck's
constant. This one, speed of light, C. This one is the wavelength. Then you get the answer as 2.65 times 10 to the power negative 19 joule. So Alhamdulillah ni sama. So tak adalah pening sangat. So which one has higher energy? So tengoklah nombor-nombor dia sahaja. 4.97, 2.65. So which one has higher energy? So kita nampak 400 nanometers has higher energy compared to 750 nanometers. So that enables us to make conclusion. The shorter the wavelength of light, the higher the photon energy. Ataupun kita tahu dah, shorter wavelength means high frequency. Dia terbalik kan? So higher frequency, higher photon energy. So betul lah yang kita belajar tadi. Proven. Okay? Alright. So wave particle duality. Apa tu? So wave particle duality tells us about electromagnetic radiation such as light is said to have wave properties. Okay, itu dah awak dah faham dah. No problem, you understood already. Light have wave properties. You understood kan? Kita dah belajar kan yang tu kan? So no problem. Now, so since light is since light is wave, ataupun since we say light have wave properties, therefore light can be diffracted and can be interfered. Kan? Kita dah belajar juga interference and diffraction. However, okay, in other part, okay, when we talk about object, object like marbles, like tables, like chair, computer ke whatever, dia kata are said to have particle properties. You know what particle is kan? Bila sebut particle, kita kata dia ada molecules, dia ada atom and so on and so forth. Because they possess momentum and kinetic energy and can collide with each other. Do you understand what we are trying to say here? So, kita sekarang ni tengah bincang ada dua benda. Satu electromagnetic. Bukan benda lah. We have to... Okay, one we are talking about electromagnets wave. One we are talking about... Another one we are talking about object. When I talk about object, you think object tu dia ada matter. Kan? Dah nak habis masa dah. Okay lah. So itu yang kita faham. Okay. And then object ni dia kata adalah particle sebab apa? Objects can berlanggar. Kan? Ada momentum. And then objects move. Therefore objects have kinetic energy. Okay, itu apa yang diberitahu tentang objects. Okay. However ni yang payah ni. Louis de Broglie, remember? De Broglie, okay, dia adalah quantum physicist. He had put forward a hypothesis stating that dia kata all particles can exhibit wave characteristics. So de Broglie kata, inilah kan, de Broglie lah nama panggilan pendek dia. De Broglie said that, okay, all particles can exhibit wave characteristics. Fahamkan tu Now, but it is very difficult to prove that experimentally. Susahlah awak buat eksperimen kat diri awak. Awak nampak tak wave keluar from your body? Tu sangat susah kan? To show the wave. Yep. So that is very difficult lah to show the wave characteristic particle bila buat eksperimen. So Louis de Broglie predicted that the wave characteristics can be exhibited by light particles. Dia kata, okey lah, objek-objek lain susah nak buat. Tapi, light particles boleh. For example, electrons. Okay. Then, de Broglie kata, okay, dia kata, he stated that a relationship between momentum of particle and its wavelength. Now, you have learned about momentum. Betul tak? Awak dah belajar lama dulu masa form 3, momentum. So, dia kata momentum, simbol momentum P. So, dia kata momentum ada relationship with wavelength. So, what is the relationship? So, wavelength equals to another formula that kita come across ni, H over P. So, what is H again? H is Planck's constant. Okay, and P tadi apa? Momentum. And wavelength is wavelength lah. Okay, lambda tu is wavelength. So, this is the relationship that he said. So, from this formula, awak nampak, the greater the momentum of the particle, the shorter the wavelength. Nampak tak? Dia terbalik kan? Dia ada kat batas, ni ada kat atas, ni kat bawah. Faham kan saya kata atas bawah tu? That means, the higher the momentum, the lower the wavelength and vice versa. Dan terbalik pun betul lah. So, kat situ, and then kita dah belajar sebelum ni. You have learned that in last time you belajar momentum equals to product of mass times velocity. Okay? Betul kan? So, therefore, when you substitute wavelength, okay, you substitute H. So, you want to substitute this P ni. Jadi apa then? Jadi mv. So we have another formula which is wavelength equals to Planck constant over mass times velocity of particle. But okay, so this is but H is very small. Okay. So kita kata this is de Broglie's wavelengths which are too short to be detected. Okay. So dia kata sebabkan itu wave ada karakteristik that we cannot observe.